This video is for my honors pre-calculus class. You should have these notes in front of you, but if not, you can just write them on paper. This is about section 1.8 in our book. We just didn't quite get to it, and this is something I'm going to reference again in chapter 2, so it's a good fit, okay? So when you're asked to solve an inequality, that means you're going to have either a less than symbol, a greater than symbol, or a less than or equal to, or greater than or equal to. But you can pretty much, if they're linear, you can pretty much just solve them the same way you would solve an equation. With equations, we could subtract 2 on both sides. With an inequality, we're also allowed to subtract 2 on both sides. And then divide by 4 on both sides to get x by itself. I can do that with an inequality as well. And I get x is less than 3. And, you know, as it says here in the writing, this is an infinite set of numbers. That is the solution. It is the set of numbers. If you were asked to graph it, let's say 3 was right there, it would have an open circle at 3, and it would be all numbers to the left of 3, because 2 makes this true, 1 makes this true, negative 11 makes this true, all of those numbers. And if I had to write this in interval notation, negative infinity to 3 is what it would look like. So I think I said that a minute ago, linear inequalities, you can just use the properties of equality to help you solve them. This is yet another linear inequality, meaning that x is to the first power. And there's a little box on the side about that rule that I don't want you to forget, which is that when multiplying or dividing both sides of an inequality by a negative number, you must reverse or flip the inequality sign. So on this equation here, the first thing I might do would be to subtract 9 on both sides. Because I only have a constant on the right side, I'll put my variables on the left side, despite this giving me a negative number. And also, by the way, I subtracted 9 on both sides. I didn't multiply or divide, therefore there's no reversing the inequality sign for that. But in my next step, when I divide both sides by negative 6, I am going to have to reverse that sign. And also at the same time, I'm just going to go ahead and simplify that fraction. So x is greater than negative 2/3. If I had to graph it, open circle, shaded to the right. If I had to write it in interval notation, would look like that. And that's probably the best infinity symbol I've ever drawn. Okay, here's another one. This is a compound inequality. I can leave it like that to solve it, but I'm going to save that for last. I'm going to take this apart. This is the intersection of 2 sets. And there are my 2 inequalities to solve. I'm going to solve the one on the left first. I'm going to add 3 to both sides. I'm going to divide by 3. The next one, I'm going to subtract 6 and divide by a negative 3. So I'm going to reverse my sign. And there's my solution set. If I needed to graph this solution set, I'm going to scroll down a little bit. I'm going to do this in 2 steps. X is greater than or equal to negative 1 means all these numbers here in pink. And then I'm going to use red. X is less than 2 does not include 2, but is all numbers going this way. And the intersection is the set that they have in common. So that's going to be, they both have -1 in them. It's shaded here, just like it's a closed circle here. Only one of them includes 2, so I can't include 2. But, oh, oops, I forgot to finish that. And then it's going to be all numbers in between. And in interval notation, that would be -1 included, so we put the bracket around that one, and then 2 is not included, so the parentheses. So just going back and looking at it, I personally kind of struggle with this other way, but I'm going to guess that a lot of you could do this just fine. I could say, well, I'm going to take 6 away. So you actually have to write it down 3 times because you're actually solving 2 equations. And then divide by the -3, which is going to reverse all your signs. And I really don't like the way that looks. You should always have your smaller number on the left. So I have to flip the whole thing again. But you can see that I got the same solution set that I had before. And that's how you write it as an inequality, by the way. But it would be the same set that I just got here.